text them and let them know I took attendance. I'm not going to bother you. All right, I think I'm recording now. Right. So, a couple of things. I'm going to start a new file, and one of the things I'm going to do, if I wasn't so on this when Rhino was opening up, I'm going to go to, see what I did there? I went to the Tools pull down, Options. You guys seen the pattern here? Every time we need to flip a setting, that's where I go in Windows, right? Okay. And here I can go up to Units on the left-hand side. I'm just going to make sure it sets to inches. I want to be very sure this is at inches, right? The Grasshopper file we're about to open up that I give you is set at a certain scale to find a certain portion of the surface that will make sure that everything will fit into the bed of the laser cutter. And if you screw up the units, you'll have to just go back and start it all over again, because it's really a pain in the rear to convert units. So again, just think about this for a moment, right? Like this is something that you should do when you start up a project anyway. Double check those units, double check the tolerance. I'm just going to leave this as inches and make sure I hit OK and I'm good to go. Now, I'm going to open up that Grasshopper file. Right, so you guys can do this back at your desks if you like. Shell Surface Options, GH, it takes you to, for whatever reason, Canvas doesn't like .gh files. It's like a text file, maybe it needs some sort of exploitative virus or something, I don't know. So it just takes you to my Google Drive and where you can download it from there. Let's see, here's Grasshopper. How I've missed you, dear friend. The sweet, sweet darkness. Here we are, all right. And I'm just gonna open up this file. Open, I don't know where this is, but I'm gonna go to the desktop, 367, project 3. Oh yeah, there it is, Shell Surface Classifications. All right, now, let's talk a little bit about this. I'm doing a couple of things here. And first and foremost, you can see that I'm generating a grid of points and I'm creating a surface through the grid. Now, I'll talk about in a minute how I'm generating that grid of points and why it's not just a flat grid of points, but that's simply it. Now, after that, what am I doing? I'm giving it a latitude, a minimum latitude and a maximum latitude, and a minimum longitude and a maximum longitude to define an area along the surface, right? So if you think about, we talked about this in curves, we have a T address, we can find a point, an address along a street. When we're talking about a surface that has, in this case, U and V, right? Latitude and longitude, we can define the rectangular plot, a quad-shaped plot, with a minimum in both directions, right? Does that make sense? And what this is set up to do is if I start to move this, right, it's going to move the patch with a certain constant width and a certain constant length along this surface, right? So it's really just up to you to sort of find whatever you fancy the most here, just by simply manipulating these sliders around. Now, if you go too far, you can go right off and make something way too small, right? But what I'm going to do is I'm going to pick a patch, and I want to re-emphasize this. I'm picking a patch that's not symmetrical in either direction. The reason I'm doing that is because when you do something that's very symmetrical, sometimes you have a hard time understanding which corner is which. I will have no problem understanding that this corner is much different than that one, and this one, that one, right? So I can easily situate this relative to the virtual quite easily just by sight, rather than having to sort of measure very precisely. Okay. So how am I doing this? All right, well, it's just simple trigonometry, as you will, and some algebra. So what I'm doing is solving for x and y, just iteratively, just sort of plotting 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, right? But then for the z coordinate for each of those grids, I'm plugging in the x and the y values as cosine plus the sine, cosine of x plus the sine of y. So what I basically did is this sort of sine wave escape. So things are moving in z as x and y sort of iteratively sort of grow. This thing sort of oscillates back and forth in z, right? Just like we would expect. All right. Then of course there's a minimum and maximum, in this case 0 to 4 pi, and 0 to 4 pi, and x and y, and blah, 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 blah. But That's all I'm doing. Then I plug all of these coordinates in to a point widget. I'm just plotting x, y, and z coordinates as points. And then once I have a grid of them, I can say, let's make a surface through that grid of points. And it does. Ta-da. Now, I give it a minimum, maximum longitude and latitude. And now I have a patch I can work with. All right. So, long story short, I just wanted to show you that, because everybody's going to start off with this sort of trig-based sine cosine geometry, right? It's a really nice and easy way to make something that is fairly predictable, mathematically defined, and doesn't, well, let's put it that way. Now, let's just leave it there. What I'm going to do, and this is all you really have to do, is sort of move these around until you found the exact thing that you want. Maybe you like it over here, and I don't know, whatever, right? I'm kind of partial to this for whatever reason. And let's see here, something like that. I'm just going to take this new isotrim subsurface, right? And I'm going to right click and I'm just going to bake it into Rhino. Boom. Now I can close Grasshopper, and I have, and when everybody does this, they'll have, you will have, a sort of master surface geometry for your grid shell. That's it. You're not going to have to make some curves of your own, lock them together, or anything like that. But this will ensure that we have doubly curved surface. Again, I just decided where I wanted it with these sliders. And you can see that when I take this last widget and select it, it highlights that subsurface green. I can right click, bake it into Rhino. Now I have a static version of that surface patch. I'm going to actually drag it out here. Now, what's interesting is you can see I have my XY plane. You can see the XY axis. And you can see that this was by default somewhere in the positive X, positive Y quadrant. A lot of the tools we're going to use to automate breaking this up into components will also populate that positive X, positive Y quadrant. So I'm going to move my shell surface out of the way, right? Right now while I'm thinking about it, and just get it out of there. Poof, get that shit out. All right, so you guys ready? That was the Grasshopper file. That was just coming up with the surface that you're going to use for your grid shell. And each of you might pick something slightly different, I would expect, sometimes dramatically different. Again, if this looked, I guess, visually like it was symmetrical, you might have a hard time then understanding which cell is which when you're trying to put in grid shell components, chain components into it. So that's why I'm purposely picking something that isn't symmetrical in either direction. Right. All right. Right. So let's run that Rhino script. You guys ever run a Rhino script before? We're going to run a Rhino script today. This will help you take this and break it up into a set of grids with notches. Just the right click. All laid out flat for you. Okay. And then we'll take a look at that script and look and see what it takes to actually write something in Visual Basic, which is complicated because it's not even object based like object-oriented based like Python is. And then maybe over the weekend, then you'll appreciate some of the things you're doing in Grasshopper, right? That you can do it that way rather than having to write script. Okay. So what I'm going to do to run a script, and what I'm talking about, again, I'll just refer back to Canvas one last time. This second file that I'm giving you guys, use it. Shell structure rhino script.rvb, or whatever it's called when you download it. But it's a .rvb, a file extension, Rhino Visual Basic. And the way to run this is to go in Rhino to Tools, and you can see that there's a Rhino script editor. So I go to Rhino script and say Edit. Okay? I'll just leave my mouse hovered over that for a minute. For those of you here, and for those of you watching the recording, that's where I'm getting that. Okay? It brings up Rhino script editor. Right, there it is. In this case, it actually shows the last Rhino script I had open, which was surface to grid shell, right? That's what you guys are downloading as well. Now, this is my buddy Andrew Cudless from Matsys, Material Systems. He's now at University of Houston. He made this like, I don't know, 20 some years ago, if I feel like, 19 years ago, 2005, right? It still runs even on Rhino 8. This was for like Rhino 3 or something, or 4. And you can see, right, what it takes to get under the hood, and this is what some of those folks at SOM and Fort Norman Foster and Partners, right, they'll hire folks just to help them do these sorts of things, to extend, to get under the hood of tools like Rhino and Revit and those sorts of things, right? And back in this time, a lot of us were experimenting with extending Rhino. It was very easy to sort of run end user scripts and things like that and develop plugins and the like at the time. But what you can see is that this actually, I don't know if anybody, let me just back up. Has anybody actually taken one of those Grasshopper files, those .gh or .gx files, and opened them up in a text editor or Notepad? It's just, it looks like this, right? It's just Grasshopper writing the script for you as you go, right? It translates all those nodes and the arguments you pass from the output of one node to the input of the other, right? And it's basically writing the script for you in real time. This is what it involves, right? So thinking about all of those inputs and outputs and naming them as variables, defining what kind of variable type they are. Sometimes they're reals or integers. Sometimes they're geometry, and so or the name of geometry, right? And so then you can see that it sort of follows step by step. There's a set of procedures like rhino.getRealNumber. All that does is tell the command line to ask you for the x distance, y distance, and sort of input parameters, right? Then names those numbers and then uses them down here later for a set of methods. And here's what it does. It also then you can basically start to break down certain things that you do over and over again and reduce them down to sort of outside functions and then call the functions in the main scripts, right? So I don't expect you guys to really think about this a lot. Unless you've done a lot of scripting. I wasn't formally trained, I just have to teach myself. And now we have Grasshopper to do these sort of things for us, right? We have on the Revit side, Dynamo will do some of this stuff for us, right? Okay. Now, I'm just going to show you guys how you can use this script, all right? And again, you'll see how this runs. It does a lot of the work for you. This is where you just sit back and sip your coffee and let your laptop do the work for you. You go, oh, this one amuses me. Let's go with that one. All right, and anyway, but hopefully seeing the back end of this makes you appreciate maybe having a visual code editor like Grasshopper. Right? It's much easier for us to sort of grapple with these things without having to also figure out the syntax of the Visual Basic, which is probably the clunkiest scripting platform I can think of at the moment, right? It's a lot clunkier than JavaScript or Python or C#. So anyway, I have this open, right? If I didn't have this open, I can just go to File, Open, and open up that RVP script. And you'll be able to see it here. You don't have to select anything. In fact, you don't want to delete anything. I'm just going to simply hit this green button that says Run Script. It's like the play button on the DVD player, right? You guys remember DVD players and Blu-ray players? Yeah, anyway. I remember VCRs and audio cassette tapes. All right, so it says, and look, the script editor, it's running the script, so the script editor disappears, brings you to Rhino, and then you look at the command line. It says, select a surface to populate with tiles. So I'll say, okay, here's my surface. And then it says, enter the number of tiles in the U direction, right? Here's where I'm going to type in some number between 8 and 12, okay? I don't go any more than 12. Think about 12 and 12. That's 144 cells. That's 144 of these. You have to laser cut and fold and then try to sort of fit it in, right? So I'm going to say, can't go lower than 8 by 8, and you can't go higher than 12 by 12. So I'll just keep it at 10. 10, let's see, come on now. 10 and 10, right? I'll go 10 cells in each direction. Enter a height for the strip. Now what this is actually asking for is each sort of rib or strip that it's going to populate here, what is its depth, right? What's its sort of structural characteristics? I'm going to say 0.75 inches. So 0.75, right? If I enter 0.75, it goes, 0.75 units. What are the units? At the very beginning, remember, I double-checked and made sure units were set to inches. All right, so, and now, when it lays out all these strips, the X strips, right? The strips in one direction, let's say the longitudinal strips, what kind of spacing do you want in between them? So I'm just going to say something maybe overly cautious here, like 20 inches between each. And then the Y distance between unrolled strips, I'll also say 20. And then the material thickness. This is important. It's going to put notches in here. And those notches need to line up. So you need to understand what the material thickness is. Right? I recommend getting something that's 1-ply chipboard, which is usually in the neighborhood of 1/32 to 1/16. Sometimes it's 0.030, right? If you buy material and then you bring it in, what I recommend doing before you run this script again is take it to Kyle over in the laser cutter room and say, hi, can you get your digital micrometer out and digital calipers, and we'll just measure the thickness of this really precise and make sure if it's 0.040 or 0.032 or something like that, right? Be very precise. So I'll say 0.03 and just hit enter. And now it's just doing a bunch of stuff for me. And let's just, it's done already. That's very quick. And let's just take a look at what it did. First of all, three-dimensionally, I populated the model with these strips. And if I go to the Properties tab, you'll see that each strip has also a name, right? So in the U direction, let's call that, like, let's say the equator, so latitude, right? I have U0 all the way to U10, right? All right, 10 divisions, 11 strips, starting from 0 to 10. That's really handy because you want to make sure that you label these things so that you know where they go, right? And it's the same thing in the opposite direction. Here I have V10. Over here, that must mean I have V0. Now, what's interesting is some of these things need to be joined together for whatever reason. I'm not sure why it broke like that. Okay. Now, remember what I said? That quadrant, that positive quadrant, XY quadrant, is now populated with all the laid out strips, right? Labeled. Okay. So we are like one or two quick steps away from putting these in an 18 by 32 box and taking it to the laser cutter room and just like cutting the crap out of the chipboard. Yeah, pretty handy, right? Trust me, it's a lot harder without scripting and without Grasshopper. I used to have to do that all the time. When I was with MBBJ, golly, we'd do a custom double curved curtain wall, and it was a pain in the rear. And it was not just like this. It would be sort of segmented into planar sort of things. But anyway, you'll see here that also has some through cut curves, right? Like you just made a box for the notches, right? In other words, it was easier just to sort of make a notch and quicker than it is to try to get everything to trim out. It'll still cut those notches. And look at this, right? It cuts those notches in one direction in U and in the other direction in V so that they really will go together. All right, so there's a couple of things here I'm just going to do, just again to show you how this workflow really only takes 5 minutes once you get the hang of it. Okay. And let's start with turning off this grid, because this gray grid is just makes me want to barf looking at it. You know, it's like chefs have like a really sensitive palate. Like our eyes are that sensitive palate, right? We're graphic people. So, all right, a couple of things. This is just one closed curve. And so what you'll notice is that these labels, they're first of all, they're at a scale. And second, they have unnecessary line work in them, just to sort of inscribe or lightly score the labels into each piece. So one of the first things I might just do really quickly is, wherever this is, why am I not seeing like a giant A or alphabet or T or something? Oh, here, okay. Okay, sorry. I'm just gonna make my own text labels. Sorry, my bad, I'm just an idiot today. It's Monday, and I did not want to get out of bed today. I'm just as human as anybody else, that's for darn sure. All right, so, and a couple of things, right? I'm gonna say make them curves, right? Laser cutter loves curves. Think of it as a printer, just prints lines with a focused beam of light rather than a focused beam of ink, right? And I'm gonna double check the height and make sure it's appropriate size. I'll just leave it, let's see here, V0. Come on now. Why won't you work? Don't know why my keyboard isn't working. Okay. Of course it's not. Yeah, I just shouldn't have gotten out of bed today. All right, well, anyway, I can sit there and like make a label V0, right? Now, really quickly, the other thing I want to do, and this is why I'm recording this, right? There's a lot of little steps. It's not obvious to you at first start. Once you do this a couple of times, then you start to remember, oh yeah, right? I'm going to go to, I think it's called Rhino Single Stroke or something like that. Single stroke, is it R something or S something? Self, yeah, here we go. Single line fonts Rhino Architect, right? SLF-RHN Architect. What that does is it gives me just a single, here, let me just see if I can get this to work. A single stroke, right? In other words, instead of going around with the whole outline of something thick, it's just going to go V, right, and 0. It's going to save you about half the time when it comes to laser cutting, right? That stuff starts to add up over time, honestly. And it's really just money for you, right? So, right, if I just do this out of the box, it's of course too large. So let me just go ahead and run this. Let's see. Let's make it a height of 0.125. Let's make it an 1/8 inch tall. My keyboard isn't working in Rhino for whatever reason. That's really weird. I wonder if this has to do with, that's really odd. Okay, it's working there. So why is it not working in the text box? It seems pretty important to me. Maybe I just need to restart my machine. But in other words, I would turn the height down quite a bit, right? Not that far, not 0, but maybe let's say maybe 1/8 of an inch, so 0.125 or something like that. I would enter this stuff in, yada, yada, yada. Let me just bring it up since my thing won't work. I'll just make it 1/2 an inch, unfortunately. That's all it'll let me do at the moment. I want to make sure that it's set to this single line font, Rhino, SLF, Rhino Architect. Right, and you can see then now it's a single line, right? Okay. And I can place these things and get rid of the old ones, right? Which I think is, some of these things are, why is it, cut it out. Yeah, for whatever reason, my keyboard isn't working correctly here in Rhino. Well, anyway, let me just save this and then I'll just reopen it, of course. Laser demo. I'll just reopen Rhino here. I don't know what's going on, but it's really odd. See if it's a Rhino issue, not a Windows issue for me. Open up that laser demo file again. Right, now really all I have to do is add those labels, move these things around inside the laser cutter template, and I'm ready to go down to the lab, right? So this doesn't take long. In fact, this is a nice automated process. Let's get rid of that. Okay, appears like some of these things are working now. Let's try this again. There we are. Oh my gosh, you take it for granted, right? Like, hey, my computer works until it doesn't. All right. So now I can add a little simple, really tiny, here's V0. I can get rid of all this other crap that they put in here. I don't want it. That's a technical term, crap. Right? Now it's just going to be a little score, right? Just a little bit of engraving. Oops. Here at the bottom, it's going to be nice and small, so it'll show nicely. And I can do that back and forth here, V1, V2, V3. Takes maybe 10 minutes, 5 minutes, who knows? It doesn't take long once you get the hang of this. All right, Now, one last thing, and that is, if you haven't laser cut before, all I do is I simply go to Google. Let's see, Google. Oh, come on, here we go, Google. And I just type in UNLV digital fabrication. And it says, did you mean fabrication, not fabrication? And yeah, okay. But it automatically takes you to the Fab Lab down the hallway. You can even go to the laser cutter. Hours in for general information, so you can sign up for a time, make an appointment, scheduling an appointment. You can visit at a certain time, blah, 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 right? So that's all these parameters. There is a template in Rhino that you can use. But simply put, it's simply this. Let me just make a box here, 0, 0, 0, and I'll just make it 32 inches long and 18 inches tall and 32 back, and close that up. And then I might actually offset curve, maybe 1/4 of an inch distance, 0.25, and just sort of set that to the inside, right? Just so I make sure that I have a margin to sort of follow. From here, I can then place these inside that 18 by 24 or 18 by 32. I might need a few sheets in order to do this, right? But all of these pieces should fit inside that sort of bounding box. Okay? So it's just a matter of me sort of dragging these things around in the right places. There's a couple of other things. One thing you might notice here, I always open up this, let me save. Let me just open up let's see, downloads. No, it's the wrong downloads. Here we go. Like downloads on the Mac or downloads on, here we go. Laser cutter template. I double check the colors, right? So it's using, I believe, red, so RGB colors, right? RGB color scheme. You guys know RGB? Red, green, blue. And the values can go from 0 to 255. So pure red is 255.00, right? Full 255 for the red, and 0 for green, 0 for blue, right? And it looks like then full blue, so that would be RGB. That'd be 0, 0, 255 for things that you want to score, right? So what I would do is then I always look at their template just to remind me of this. Let me just go back to laser demo. And what I would do is then start to put things on different layers for color, right, based on what I want to do. You'll see that this actually gives you a sort of zigzag scoring pattern if you need it, right? That's to encourage some of these things to be a little more flexible and bend and flex in its planar direction than its sort of normal direction. Because that's what you're doing. You're basically making you're taking the isoplans from the surface and those curve in multiple directions in order to do this. So that's why I want you guys to use something that's flexible, like one ply chipboard, because this stuff will need to bend with it. Yeah. What's great is that it starts to get quite rigid once you start to put it together and get it all off to place and start to add the componentry in, right? Inherently starts to gain stiffness. And so from here, I might, again, just start to lay these things out to make sure that they all fit in here, and trying to, oops, wrong handle there. Trying to minimize waste and maximize as much yield as possible, right? So oftentimes what I find myself doing is I will, let me demonstrate this. First, let me move this guy out of the way again. Although you can see that for an exploded axon now, it's really handy to have this three-dimensional version with all of these ribs as well, right? Now I can start to pull these things apart and talk about the process of going from a surface to a set of ribs with a bunch of things on top, etc. Right? Let me just select all of these things and pull them down here a bit. Oftentimes what I'll do is working in top view, I will just try to find a way to tighten these all up and figure out a way that they sort of nicely nest together. all these things can, spoon each other, so to say. There you go. There's the commentary you were missing, the digital fab. All right. But again, I can go ahead and do this. Then I can rotate them as a batch and group and make them minimize the waste on that 18 by 32, right? And that's the key. I think part of this is, again, I could probably get these a little closer together if I start to rotate them about. Again, I just want to keep those labels so I know which one is which. You don't want a gigantic jigsaw puzzle at the end. You want to know which piece is which. And again, you can always refer back to it. You say, okay, this one is V4, and then you can come back to this and say, which one of these is V4? That's V9, so this must be 8, 7, 6, 5. This one is 4, right? Right? Oh, come on, right there. So again, you can use these graphics for your own reference. Right? It's really helpful. Now, the reason I'm using these plastic zip ties is because once you start to put these together, you start to put the notches in, and you put a next set in, the other ones start to pull out. They want to sort of pull out. So I found that simply having a bag of zip ties and just sort of where I need them, or maybe alternating them, right? I was able to sort of hold these in place without having to glue everything. Because what you want them to do is you think about two things notching. They're going to do this. You just don't want them to come unlocked, right? So you want to sort of lock them together, but you still want them to be able to flex as you're putting this thing together, and then have to find an equilibrium before you start to glue things and lock it in place. So this gave me that sort of flexibility of keeping it together, locked in, while simultaneously being able to sort of flex and find that equilibrium point. So from here, then I can start to zap things with glue, snip some of these things off, zap with glue, let it dry, and then it's ready to receive shading components. All right, I can pass these around a bit, so you guys can sort of get a sense of, these aren't the best ones, but they are indicative of some of the problems and challenges you're going to run into. This one you'll see, if you look at the underside, still has the blue tape where whoever the author was, was taping these things in before gluing, and then suddenly found themselves like having to remove a lot of painter's tape, and sometimes it was mixed in with the glue. So keep that in mind, right? Sometimes you do these things with the sort of I'm just going to glue things together model mentality. There are ways of sort of thinking about designing connections. Because only half of our buildings are glued together, right? Like the drywall is glued and spackled and painted. But a lot of other things are bolted, screwed, nailed, or otherwise fastened together. All right, so some things to think about. On Wednesday, I do recommend that maybe you bring some scissors or an X-Acto or a little cutting board, whatever you need. I'll have 8.5 by 11 stock printer paper, that's all we'll use. That's all we'll use. But we'll start to design the shading components that will go on top of these. Between now and Wednesday, you can easily run this, it only takes 30 seconds to run that script. So theoretically, you could run it like, a million times. But, you can run it once or twice. You can then, see how it works, get the feel for this, go through the steps, motions, get some chipboard, look for the 1-ply, make sure that it's flexible, it'll flex and give you some bend. And then, run this again with that material thickness. And then sign up for a laser cutter time. Go to the Fab Lab, go to the laser cutter and sign up for some time. Right? Probably need about half an hour, I think, would guess. If you're not sure how much time you need, you can always show them your files and say, how long do you think this would take? And they can maybe give you a better ballpark than you might if you haven't done it before. All right? Does that help a little bit? All right. Yeah, baby, we're going to make some stuff now. We're going to get our hands dirty a little bit. And it's going to smell like a laser cutter. I love the smell of laser cutter in the morning. That sort of burnt chipboard smell. It's better than the burnt plastic smell. That stuff's really nasty. All right? And look, we just went through it quite a bit, didn't we? Like, we just generated a bunch of sine and cosine waves, sampled a portion of it, broke it up into a bunch of ribs, laid them out for laser cutting, so now you're just like one step away from walking down the hallway and laser cutting, right? And it didn't take long. Now it's going to take you a little longer going through the steps the first time or second time, right? But that's the key, right? We're automating a lot of stuff here by getting under the hood, in this case using a script. Don't worry, you will learn some stuff about parametric design in Grasshopper that does the stuff that you were doing in the script when it comes to sort of populating that surface with your shading components. But again, the thesis here is that if the shading components are ultimately going to be made out of sheet material anyway, that's what we'll do. We'll start physically prototyping them with sheet material, right? I always do that anyway. Like before I start to screw around in Grasshopper, I have like a bunch of drawings and diagrams and maybe even a couple of quick prototypes, or I mean, it's really easy to do with paper. You just bend it, score it, fold it, right? So that's the logic we're going to follow. All right. Any questions? I've broken this up so that this process becomes really quite easy. It's a matter of you just doing it once. Sometimes you'll make some mistakes, or you won't have the notches just right, or they're too much, they're too thin. And then suddenly you're really starting to flex the ribs trying to come in place, right? So dialing that in might take more than once. You're going to prototype this multiple times, right? That's why I prefer using things like chipboard and maybe some cardstock for you have some intricate folding to do with your shading components. They're not expensive. They're fairly inexpensive. So that's important to me to make sure that we're not breaking the bank. That again, we encourage experimentation. That laser cutter going from bits to atoms, right? It's a strange process, and I think you'll come across this. Some of the things you took for granted in Rhino, when you draw a line or a curve, right, with a certain precision, right, maybe 3 or 4 decimal points of accuracy, don't hold so much weight when you're trying to build it out chipboard, right? Or you even buy a sheet of chipboard, you realize the corner's a little bent, and right, nothing's really perfect in the real world. Materials aren't, right? So trying to understand and negotiate that sort of perfect virtual environment, and how you can begin to understand and think a couple steps ahead, translating that to an imperfect but real, sort of tangible prototype or building, edifice of some sort, right? I think is key. That's what we do as architects anyway, right? Except we're not usually the ones that are laser cutting the stuff and then putting it together. All right. If there's no questions, I'll just quickly show you guys just a little more, right? So it looks like when I ran this script, for instance, look at this. It gave me the V strips on the layer, the U strips on a layer, the score layer that's green, and then the cuts for the notches on red, right? So I could simply just do this. Let's just change that layer to red. Ta-da! Let's change this layer to red. Let's see, 25500, yep. And now it's ready to roll, right? Except I need to replace these labels. So maybe I say V1. And I get rid of this text in this one, right? And I just, continue to just sort of do this, right? So, but we've sped things up considerably with running that script, right? Then maneuvering these things around and trying to make sure that they all land. Oh, that score layer needs to be blue, right? We said that. So let's put that on blue. Let's go with blue. Let's see, 00255. That's it. All right. And now that bad boy is ready to laser cut once I put it in here. Okay. All right. Well, if there's nothing else, on Wednesday, again, we'll just do a hands-on sort of quick workshop. We'll come up with a few set of quick rules, but you're basically limited by what you can do with a piece of paper of limited size within a sort of a quad cell. And then what we'll do after that, next following week, is translate that into Grasshopper. And then you'll be able to populate this further, not just with structural components like you did with the script, but with the shading components that sit in each of those cells in the structural grid. Structural waffle. All right. Well, I have nothing else today. Yay, we're done early. No? All right. Oh, and of course I didn't turn this off.